Alright guys, I'm going to do Module 2, Topic 2, Angle Relationships. Standard for this topic is GR 1.1. I'm going to prove relationships and theorems about lines and angles. Solve mathematical and real-world problems involving postulates, relationships, and theorems of lines and angles. Our objective, you guys are going to use the properties of perpendicular lines to find the measure of angles. Our essential question for this topic: how do complementary angles compare to supplementary angles, and where can you find them in the real world? We'll answer that by the end of this topic. We're going to start with our bell ringer. You guys know in class you guys will do this, and then we compare answers afterwards. So pause the video now, see what you can answer from the bell ringer. This is going to cover some topics that we talked about in the previous lesson, Module 2, Topic 1. And then after you pause a second, then we'll work this out together. I'm going to take about 3 seconds, and then I will get started. Okay, bell ringer, use the figure. Number 1, angle 1 and what other angles are vertical angles? So if you recall from yesterday, when two lines intersect each other, they create vertical angles. In this case, 1 and 4 are vertical angles. So this is 1 and what other angle? So angle 4 will be the other vertical angle to 1. Number 2 says angle 2 and what other angle or angles are vertical angles. So 2 and 3 are directly across from each other, and those are vertical angles. So this is 2 and 3. They're directly across or up and down from each other, those are vertical angles. Alright, number 3. Angle 4 is adjacent to what other angles? Remember yesterday, in the previous lesson, adjacent means next to. So what's next to 4? Well, if we follow this line here, we'll see that 2 and 4 are adjacent. Angle 2, angle 4. And then if we follow this line, see that 3 and 4 are next to each other. So it's 2 and 4, and let's make this in the other color here. Angle 3, angle 4. Alright, number 4. Angle 1 and what other angle or angles form a linear pair? So, as we learned yesterday, linear pair, they share a line. So 2 and 4 share this line. Oh, sorry, 1 and what other angle? My bad. Got on linear pairs there. So 1, if we follow the blue line here, 1 and 2 are linear pairs. So 1 and 2. And then if you follow this line, 1 would be 1 and 3 would be linear pair. So just do it this way. So 2 and 4, and 3 and 4, and then 1 and 2, and 1 and 3. Alright, number 5. If the measure of angle 2 is 114, then what are the measures of angle 1, measure of angle 3, and the measure of angle 4? 1, 3, and 4. Alright, so 2 is 114. So 114. So we already know that the measure of angle 2 is equal to the measure of angle 4 because they are vertical angles. So if 2 is 114, then 1 is also 114. Okay? Sorry, 3. I keep calling that 4. Excuse me. Measure of angle 3 is also 114. Okay? So we got that. And we also know that 1 and 4 are congruent. So the measure of angle 1 is equal to the measure of angle 4. And both of those are going to be 180 minus 114 because they are a linear pair. 180 minus 114 is 66. So we know that angle 1 and angle 4 are 66 degrees, and angle 2 and angle 3 are 114 degrees. Fix this. Measure of angle 3. There. Okay. Moving on. Guided notes. Complementary angles. Two angles with measures that have a sum of 90 degrees. So complementary are 90 degrees. Supplementary. These are two angles with measures of the sum of 180. So complementary, 90. Supplementary, 180. We're going to talk about that until you guys are tired of hearing it this year in geometry. So let's go down here. So right here we're talking about complementary angles. Their sum equals 90. You notice that these two angles, TRS and QRS, so we have 67 plus 23, guess what? Equal 90. These two guys, angle TRS and angle QRS, are complementary. Look at these two, 60 plus 30 also equals 90. So angle JKL and angle ABC are complementary. Alright, over here we have the supplementary. Angle DEF plus angle GHJ is going to equal 180. Write supplementary and get over to the other boxes again. Here we got 135 plus 45. Those equal 180. So these two guys are supplementary. So angle UVW and angle XVW are supplementary. Okay, recall from previous lesson which special angle pair from lesson 2.1 is supplementary, and the answer to that is the linear pair. As I mentioned above, anytime an angle separates a straight line, you know, a straight line's 180 degrees, so therefore these two angles together would equal 180. Alright, flip over page 7. Scoot the papers down here. Oops. Alright, page 7. Number 1, top left. Angle A and angle B are complementary. One of those two words, complementary. Angle A is 30 degrees. What's the measure of angle B? Well, recall from the previous page, complementary, that means they're going to equal 90. So if angle A plus angle B equal 90, and we know that angle A is 30, all we have to do is subtract 30, and angle B is 60 degrees. Alright, number 2 is a you-do. Pause the video right here. You're going to wait about 3 seconds, see what you can come up with, and then you can watch me work it after this, and let's compare answers. First thing we're going to correct is supplementary, that's misspelled. Sorry about that. Alright, angles C and D are supplementary. If angle D is 70, what's the measure of angle C? Alright, supplementary, 180. So angle C plus angle D equal 180. Angle C plus angle D, they told us, was 70. Subtract 70 from both sides. So angle C is going to be 110 degrees. And moving on, number 3. Find the measures of two complementary angles if the measure of the larger angle is 5 more than 4 times the measure of the smaller angle. I know how much you guys love word problems. So, we have two angles that are complementary. We know up here complementary equals 90. Okay, so we have two angles. Remember I told you guys when they give you two things and tell you one's larger than the other, usually the smaller is going to be x. So x plus, now the larger angle is 5 more, so it's 5 more, so plus 5, then 4 times the measure of the smaller angle. So 4 times the measure of the smaller angle, 5 plus 4 times, there we go. So smaller angle is x, this is our larger angle, they're complementary so they equal 90. So let's combine like terms. We have a 4x and an x. Change color here, so 5x plus 5. 90 comes down. Subtract the 5, both sides. We got 5x equals 85. Divide both sides by 5. And x is equaling 17. Now they said find the measures of both of them. So smaller angle, x equals 17. Larger angle, 4x plus 5. 4 times 17 plus 5. I'm just going to call the larger angle L. So 4 times 17 is 68 plus 5. The larger angle is 73. Now we can check our work. We know that two complementary angles will equal 90. 73 plus 17 equals 90. So we're good to go here. Now number 4. Pause the video. See what you can do. So the difference. Well, I'll pause the video and we'll do it all at one time instead of me trying to help and then picking it back up. Okay, number 4. The difference between the measure of two supplementary angles. Supplementary is 18 degrees. Find the measure of each angle. Okay, so two angles supplementary, so we know they equal 180. And it says the difference of the two. So let's see, the smaller one will be x again, and the larger one's going to be, it says the difference of the two measures, so it'll be x minus 18. So you're going to go x plus x minus 18 to equal 180. You have an x and an x, so let's go 2x. And I add the 18 to both sides. Oops, 18. 2x equals 198. Divide both sides by 2. X will equal 99. Our smaller angle is 99. No, well, our larger angle is 99 in this case. And then our other angle, so we'll call it S, equals x minus 18, equals 99 minus 18, which is 81. So we add S for our smaller angle, sorry for the confusion, plus X, our larger angle, 99 plus 81 is 180. Okay, moving right along. Bottom of page 7 here, guided notes. Lines, segments, or rays that intersect at right angles are perpendicular. Perpendicular. Segments or rays can be perpendicular to lines or other line segments and rays. The right angle symbol indicates that lines are perpendicular. The right angle, that's the little box. I showed it to you guys last week. Just draw it here, little box. Let's make it a different color than the angle. How about that? Little box. Perpendicular lines intersect to form 4 right angles. It's like over here, perpendicular lines intersect to form congruent adjacent angles. So these two angles, because they're next to each other and they're on the same line, they're both 90 degrees, they're both congruent. And see the same thing over here, these guys, because when these two intersect, when they form one right angle, they form 4 of them. It tells you down here, angle AEB, BEC, DEA, and CED are all right angles. Okay, bottom of page 7. Number 5. Given the measure of angle HLG is 2x plus 7, and the measure of angle GLJ is 6x minus 37, solve for the measure of angle GLJ. Alright, so notice here we have this box. Now I want you guys, I'm going to try to zoom in just a little bit and readjust our camera here. So we have our little box, but notice our box goes to this line and this line, so it's not angle 4, it's only angle 2 and 3, which is GLH and GLJ. So these two are complementary angles because they make a 90 degree angle, so we're going to put them equal to 90. Alright, so HLG, they said, was 2x plus 7. And they told us that GLJ is 6x minus 37. So we're going to put both of these guys equal to 90 because they're both part of this box here. So 90 equals 2x plus 7. I'll do all these in different colors here. Plus, even though I reversed them, 6x minus 37. Now let's combine our terms. We have a 2x and a 6x. So 2x plus 6x is 8x plus. We have a negative 37 and a positive 7. Negative 7 minus 37. Cross that out. We'll just make it minus 30. Still 90. Okay. I'm going to add 30 to both sides because we had a negative 30. I have 8x is equal to 120. Divide both sides by 8. X is going to be equal to 15. Okay, they want us to solve for the angle, the measure of angle GLJ. And that was, I'm going to just put it under here, 6x minus 37, which is 6 times 15 minus 37. It's 6 times 15 is 90 minus 37, angle GLJ is going to equal 53 degrees. Hoping that wasn't there the whole time. Alright, pause, do number 6, and then come back. Scoot over. Number 6 here. Consider the diagram below. Find the value of the variable. What's the variable? Well, that's x. We got 2x here. We got 5x minus 22, and we have a little box. Little box means complementary. So these guys are equal to 90. That's going to be 2x plus 5x plus, minus 22. Minus 22. Okay, 5x and a 2x is going to be 7x minus 22. 90 comes along. Add the 22 to both sides. 112. 7x divided by 7. X equals 16. And this time they asked for the variable, which was x. Gave them x equals 16. Flip over here to page 8. Oops, page 8. Alright. Page 8. This is what we do. Determine whether each statement can be assumed from the figure. Explain. Alright, A. CE and CF are opposite rays. CE CF, and they both start from C and go opposite ways. So yes, that is true, and they share a common endpoint, which is C. Common endpoint C. Alright, part B. Angle BGC and KGC form a linear pair. Well, let's see. So we got KGC and BGC. And yeah, you can see that GB goes this way, GK goes that way. So those are opposite rays, so yes, this is a linear pair. Opposite rays. So the whole thing here would be 180 degrees, which makes those linear pair. Alright, part C. ABJ and CBG are vertical angles. Okay, let's see. Back to red for a minute. So ABJ, so this guy, and you go CBG, so this guy. And so this line AD and this line JK intersect, so for C, yes, these guys are vertical angles, and it's because those are intersecting lines. Okay. Excuse me. All right. Part D. Let's see. So BCG, so this one, and DCF. Whereas the DCF are congruent. So they want to know if this one, this red guy, and this one are congruent. And, well, let's see. So they're both on the same line, but there's really nothing else that we've learned, or nothing else that this diagram can tell us to indicate that they are congruent. So, no, not enough info. We're only going to write not enough info for the first one. It's going to be the situation for any that we call no. Alright, number E. BE and IF are perpendicular. Alright, so here, let's see, line BE. Oh, that's already red. Let's make it blue. So line BE and IF are perpendicular. Well, if they were perpendicular, they would make a 90-degree angle, so we would have a box on either side for both, and we have neither. We have no other indication, so make it a different color. No, not enough info. F. Angle EBC, so EBC, so this one. And GBC, so this guy and this guy are complementary angles. Well, so it kind of looks like this is, they're perpendicular, and it kind of looks like this cuts it in half. But we cannot go by what it looks like. We have to go by the information. We have no box, we have no indication, so no. Again, not enough info. G. Angle ICH and angle HCD are adjacent angles. Alright, so let's see what we're talking about here. ICH, so here, and HCF are adjacent angles. Well, so we'll go here and here. They both share this side. So the answer to G is yes. Common side. The common side is CH. Alright, number H. BC is an angle bisector of ECG. Okay, so they're saying that BC, this line here, bisects this angle. Really looks like it does, but unfortunately we need proof, and we have none, so no. Alright. So bottom here, let's answer the essential question. How do complementary angles compare to supplementary angles? And where do you find them in the real world? Well, did you say that 90 degrees is what we get for complementary angles? And 180 degrees is what we get for vertical angles. So it's a 90 versus 180. And as far as where you find them in the real world, you can find angles everywhere. If you look at any house, bricks on the house, there's angles to make those bricks. Tiles, square tiles, they're going to have a square tile is going to be going to have 4 right angles. Your walls, like I said, you can look around anywhere and find these angles in the real world. So yeah, that's it. Complementary again, 90. Supplementary is 180. You're going to hear that for the next 170 something days. See you guys in class. Thanks for watching.